All right. Well, I think we'll start. Welcome back to the second workshop. Today we're going to focus on sourcing parts. I'll go over a bit of the bill of materials on your schematic editor, and then we'll go right into the fun part, PCB design. So to start, I will begin with the bill of materials, where to find it on your schematic editor. To do that, I am going to open up our schematic. If any of you fell behind yesterday, I believe my files were sent out to you guys. I'm not too sure. Yeah? So you can always open that up. And put up your hands in the back if at any point you can't see something and you're wondering what some text might say. But this is what we had last time. Now, first of all, what is a bill of materials? It is your parts list, basically. All of the parts that you need to create this schematic. With large schematics, it's a lot harder to count parts. I'm sure by looking at this circuit, you can easily put together what's needed, but for the larger stuff, a bill of materials is usually very, very helpful. To do that, I believe it is just this here. You can generate a bill of materials, and when you do that, it creates a file. And I believe you can have different presets, formats, CSV, comma separated lists, various different ones, or you can create your own. And then if you go to the Edit tab here, you can actually see what components you've got. I use the Edit tab more often than I export. But in here we can, see our battery connector, our LED, all the transistors it piles together since they're all the same. Resistors, and it combines like values as well. So that's the bill of materials. Now, the next thing I was going to go into, anyone have questions on bill of materials? Pretty straightforward. Cool. All right, so then moving on is actually sourcing the parts. In our case, we already had the parts sort of on hand, so we were designing with what we had. But say you have a circuit that you need to get parts for, you don't have them. You put the schematic together from calculations or maybe someone else's design, and now you need parts. To do so, in North America, we've got DigiKey and Mouser, which I believe DigiKey is North American, but Mouser is worldwide. Correct me if I'm wrong, maybe DigiKey is also worldwide. But these two websites are sort of the largest parts distributors. And today we'll use DigiKey. I've used DigiKey, industry uses DigiKey, very popular. So I'll just go over a few components, like resistors, or maybe more specifically a transistor. But to start, resistors, you can find a lot of components just by typing in what you want. So if I can type resistor, and I'll hit enter. Now we're given this selection. Now, what are each of these things? Usually they'll describe it. A chip resistor is a surface mount resistor. Or you can get through hole, which is what we're using in our schematic. You can get arrays, you can get a bunch of stuff. They even have capacitors for whatever reason in the resistors dialog. But yeah, I'm going to select, let's see what through hole has. Okay, so it's the same with Mouser as well. You'll see at the top row here, you've got your filters. Like resistors or capacitors or transistors, everything has their own specifications, their own values, their own tolerances and all that. And manufacturers will produce a lot of various different components. So we usually find what we need by narrowing it down using filters. And in our case, say we go back to the schematic, we have two 10K ohm resistors. So let's find a 10 kilo ohm resistor. To do so, you can, if you already have a series on hand, you can select, these are sort of like the make or model of resistors. You can get different packaging, but most often used is the resistance filter. So we can go through here and we can set a range if we're trying to find multiple values, or if we're trying to find 10K ohm, we can scroll through the list. Can be a bit of a long list. There we go. Okay, so we're in the K ohms. Let's see here. That's way too slow. 7, 8, 9, there we go, too far. Okay, just like that you can get fairly close values. I know some values don't exist. Typically, component values for passive components, such as resistors, capacitors, and inductors, they'll follow what's called a standard value series, which is based off of the tolerance and all that. The most common used is the E series of preferred numbers. Wikipedia has a great page on that. And then I believe the schematic best practices document also has a little excerpt on that. Yeah.
What's the difference between the 10K ohms and the 10,000 ohms? Is it just the same thing?
It is the same thing. It's just how it's written. Actually, I could select both. It would probably give us similar results. It could also be that this 10,000 ohms has a much finer tolerance because they're defining more zeros in the name. That tends to be a pattern as well, as the more trailing zeros you see, the higher the precision of it is. So that is also a key factor. And speaking of tolerance, actually, you can select tolerances. 5% is sort of being phased out. We're getting more into 1% is industry standard, and all the way down to 0.1% for some of the more precise stuff. Well, actually, it gets even more precise if you want. With tighter tolerance, of course, comes extra price, extra cost. So I'll select 1% and 5% seem to be the most common. And in this case, I'll just hit apply. That's all we need for filters. And we're given a list. And from this list is where I start saying you consult the data sheet, figure out what parts suit your requirements. The datasheet icon, the PDF icon here is how you access the datasheet, or you can actually click on the component, go to its page, and you can look at the datasheet here. And when you pull up a datasheet for a component, of course, every manufacturer lists different information. Sometimes they list their own, how they name their components and all that, and of course, commonly the electrical specs. So yeah, that's resistors. Just a brief overview. Of course, we're not using these components in our circuit. I just wanted to show you sort of the process. And yeah, on DigiKey, for instance, you can add to a list with the quantity of parts and then use that list to create your order the parts. When you get your board in, you can put it together, that kind of thing. And then I guess actually I'll do transistors next, because that's a little bit more of a complicated thing. So transistor, I'll just start with a generic search. And when we go in here, we can see different options. Bipolar transistors, BJTs, those are what we're using in our schematic. But you also have MOSFETs, you have JFETs. These are all different types of transistors. They all operate differently. And I believe in later courses, if you are in electrical, you will learn a bit about them, or if you're in computer, I believe you do learn a little bit about them as well, computer engineering. So I will go with single bipolar transistors, since that's what we are using. And if we scroll, you can see a lot of them are surface mount. That seems to be the standard. But we're looking for through hole for our circuit. So I'm going to scroll through the filters here. Actually, we should specify the transistor we're using is an NPN transistor. BJTs have NPN or PNP, different types of polarities and structure to them. But in this case, we're using NPN. And I'm going to scroll through here and find the package type. Of course, as you're designing your circuit, requirements are different. So you'll be utilizing different filters depending on your application. But in this case, I can select through hole right here on mounting type, and that narrows down the filters. We can select the package case, which I believe we were using a TO92. I'm just trying to see if I can find the same transistor on DigiKey. I'm also going to search. It's under a different name nowadays. Different, sure, long, short body, and that works. And I'll hit apply. And then, oh, look at that. Right there is our first, that's what we're using in our circuit, is a 2N3904, I believe, suffixed with BU. The data sheet will have more on why it's got that suffix. But here you can see it's this component right here. And of course the data sheet has all of its specifications and characteristics, as well as at the bottom, most commonly is the physical dimensions of the component. So you'll know what you're putting on your board alongside the surface mount and so on. So if you ever need to know what a component does, the data sheet says it all. So, can never say it enough. Consult the data sheet. Okay, so that's sort of the ins and outs of sourcing parts. It's just filtering, going through, reading data sheets to find what components match your requirements. Any questions? Any other things you want to see on regarding this? No? Okay. Then with that all said and done, we can move on to actually creating our PCB. I'll close out of that. Okay. So from the schematic window here, we are able to create our PCB just by hitting this icon. Alternatively, if you open up the project and you already have the schematic done, you can also open up the PCB by double-clicking this or clicking the PCB editor. In this case, I'll go the easy route and I'll click that guy, and it'll open up a new window. All right. So I'll go over what each thing does within the schematic editor here, or the PCB layout editor. Same things on the side. We've got all of our grid options, and then we've got our units. I always keep it in millimeters. One thing I always enable is the full window crosshair. That's entirely preference, of course. We've got our rat's nest. I'll go into what that is once we start putting our footprints on the editor. And additionally, we have some just visual options, which I can play around with once we start drawing. On the right here, however, these are more crucial, I'd say. These are your layers. So if any of you have ever used Photoshop or any sort of applications like that, GNU, GIMP, and all that, we've got, usually there'd be layers to your drawing. Same thing with PCB design, we have layers. Each layer defines sort of its own thing on your board. For instance, FCU is pretty explanatory. That's your front copper or top copper layer. And then BCU is your back copper layer, bottom copper layer. So those two are pretty crucial. Those are what we're going to be drawing all of our traces with. And then of course you've got your adhesive layers. These are all manufacturer layers. We don't need to use adhesive, so I'm going to hide those. And of course there's solder paste layers, the paste layers here. We don't really need those either. Silk screen, I'll get into that a little bit more here. But I will hide pretty much most of these. You can hide user comments, eco, edge cuts. This is important. This is how we tell the manufacturer where we want the actual PCB to be cut. So we'll keep that on. Margin and courtyard, we'll keep those. Fab, I will turn those off for now. And of course you have your own user-defined layers, which we don't need. So, and if at any point you want to turn off or turn on a layer, you can just hit the little eye icon to make it visible or hide it. There are plenty of other options. I've actually never really needed to use this objects menu, but it is useful. It's got its function, and of course there's your nets. So yeah, and you could also do selection filters. If you have a large design and you need to select a certain area with your select, you can actually choose what that option will capture. And yeah, you could also set presets. Especially if you have a large project, it's helpful to create a preset. But for now, we will leave it as is. Okay. So that's pretty self-explanatory there. The top row is similar to the schematic editor, except we have a new sub-row here with the track, net class, vias, all that. We can set this all up by hitting our board setup. This is a crucial first step when creating a PCB. We have a lot of options. And oh yeah, here we can actually disable certain layers. I'll leave them enabled for now. But we can disable all these layers in the stack up. Actually, I believe I have a slide on stack up. Bill of materials, went through that, PCB layouts, okay. I completely forgot about this section of the presentation. So, what is a PCB? Let's start with that. A printed circuit board is comprised of a non-conductive substrate, typically fiberglass, and it's got 2 layers of copper on each side, basically really thin sheet glued right on. And that's pretty much the most rudimentary circuit board. Now, a brief history, because we didn't have PCBs back then. Originally, especially in old electronics, it was point-to-point wiring, where we would wrap leads of components around little pegs or around each other and solder them on and secure them. And then we moved on to hand-drawn PCBs. That would be where an electrical engineer would actually sit down at a drafting table, draw the traces, and then either that would be directly printed onto the board and etched, or optically using a negative, sort of create a mask and then etch it that way. Which that process sort of led into our electronically designed circuit boards, where instead of hand drawing, we use a computer to speed up the process and create finer details. And yeah, this is where I would have gone into the KiCad, but yeah. All right, now we design. So, stack up. This is where we were, caught up now. A stack up is essentially the definition of every single layer of your PCB. You've got your top layer copper, and then you've got what is a core and a substrate. Now cores are sort of, if you have a multi-layer PCB, it'll be sort of comprised of your main mechanical substrate alongside the 2 layers, and then they would put another layer of substrate on top and then the other layer of copper and sort of build it up that way. In our case, we're using double layer PCBs, so this figure on the right here sort of explains it better, where we've got our main substrate and then the copper layer, and then of course sometimes, or most times, you'd have a silk screen on top and a solder mask on top to keep the copper from corroding, keep solder from running across all the other traces and so on. When you make your own PCBs or etch your own boards at home, if you ever care to do that, the solder mask can be a bit of an extra step that I don't do just because it's a pain. But when you get it professionally manufactured, that's always a given. It'll always come with that. And yeah, it can get pretty complicated. On a PCB, you'll have different sort of ways of connecting layers, mainly through vias. And a via connecting top layer to bottom layer is just known as a via, while you've got different names for the vias going between layers, especially on the internal layers. I believe I numbered them. Oh, yeah, it's right, written right there. So going from your surface to a layer just underneath would be called a blind via, and then a buried via is one that's completely buried within the PCB. And then you've got a through-hole via, which is going through the entire board. Just slight definitions. But yeah. All right, now we can go back to the editor and sort of figure out our stack up, which I believe this menu here, we don't really need to touch it unless we plan on doing a multi-layer PCB. In our case, we're just doing 2 layers. You can see the dielectric is defined. You can change what dielectric it is. FR4 is industry standard. It's fiberglass with epoxy. And yeah, there's different options though. I believe if I go in here, yeah, you can choose various. Kapton is sort of, if you want to do a flexible PCB, Kapton would be chosen. You can even, ceramic is for like high precision stuff. But tons of options, and I believe you can add your own just at the top here. The epsilon R and loss tangent, those are RF characteristics, dielectric characteristics. So if you know that from your board, or if you're using some random substrate, you can define it there. Yeah.
Just curiosity, when would you use a flexible PCB?
It's a great question. So if you've ever seen within, I don't know how many of you have really opened up electronics. I, as a kid, always opened up electronics. Whenever you look at, say, connectors between 2 boards in a laptop, for instance, you might see sort of a yellowish connector with copper traces on it. That's made of Kapton. It's a flexible, it's used as a flexible substrate, right? And then you can connect various boards that can be moved around. Additionally, you could also use it in, say, a hinged component on maybe a laptop display, or if anyone grew up with a DS, Nintendo DS, those ones have ribbon cables in them and flexible PCBs. So, very versatile. Additionally, sometimes you can use them to create heaters. I know in industry, I've used them to create sort of a heating pad for an LCD display so that it could stay warm in colder climates. So yeah, but in this case we're using FR4. We can define the thickness of the board here. Manufacturers have their own sort of specs and tolerances, which I will get into in just a second here. We'll need it to define some things. But yeah, play around with this if you ever care to. I'll leave it be for now. That way we don't complicate the project. You could also choose finishes. We'll leave this for now. But the finish would be like plating the copper with various stuff like nickel or lead or gold if you want to go expensive. Yeah, and of course there's solder mask, solder paste. All of these menus here, the manufacturer will be able to see what options you chose in the files that you export, but we'll leave them to the defaults. This is for text and graphics. Now, the big one here is design rules. These basically prevent you from sending a non-producible board or files in general. So every process has its capabilities and its inabilities, and our manufacturer that we're going to choose today will go look at their website and see what they have. Most manufacturers, if not all, will sort of have a web page on what they're able to do. That way, when you send your design or design your board, they'll be able to manufacture it. So to do that, I believe, not sponsored by the way, I'm going to use PCB Way, just because I'm familiar with them. PCB Way, tolerances, let's see. Wow, the internet in this room is not the best. There we go, manufacturer tolerances. So when we go here, it'll give us a list. According to PCB Way, they're able to do 1 to 10 layers. They can do FR4, which is what we chose. That's a big PCB. They can do some pretty big boards. And then you've got your board size tolerances, board thickness abilities. And actually, I think right here they specify sort of their standard sizes. Board thickness tolerance, you've got your different thicknesses of layer or of copper. Typically, you use 1 ounce copper boards. That's where the copper layer is 35 microns thin. And then you can specify the inner layers as well, which is usually 1 ounce. Drill sizes, that would be your limit on how large or small of a hole you're able to drill in your board. Minimum width of annular rings. I should probably go back and show you what an annular ring is. So on a board, when you have a through-hole component or a via, normally you'd have a ring of copper around that hole so that you can actually solder to it. We call that our annular width, the width of that sort of donut, that circle. So KiCad's really nice. It's got the icon to show you what that measurement represents. And that's sort of just the width there of the inner and outer diameter of that circle. And then, of course, you have your minimum via diameter, the smallest diameter of that ring. So going back to the manufacturer tolerances, you can see that the minimum is 0.15 millimeters, which is fairly small. Typically, I go with 0.25 or 0.3 millimeters. But yeah. Manufacturer tolerances, their website has everything, and normally what I'll do is I'll just copy paste them right in. So throw that in there, minimum via diameter, I'll search for that. Of course, the naming between the software and the manufacturer will vary, so you sort of, you have to infer what each of these measurements are representing. But let me see. .2. And if you don't know, it's always good to err on the edge of caution, and it's 0.2, but I'm going to say 0.25. Okay. And then I'll look at the manufacturer tolerances for the clearance. So that would be the minimum distance between traces. Usually that limitation is set on the mask, what they use to cover the copper to then etch afterwards, where they put it in a bath of acid. Sometimes you can only get that mask to be so thin. So in this case, I think board thickness, minimum trace, and spacing. Okay, so the minimum trace width and the minimum spacing between traces is 0.1 millimeters. So if I go back here, I can set that to both of these. Now, the trace width itself is the width of your copper connections. 0.1 millimeters is fairly tiny. I will set the default later on. Minimum connection width, I'll set that similar to the trace. All right, and I'll keep the rest default for now. It takes a little bit of time to go through. Usually what I'll do is I'll have a screenshot of all the options and then throw it on my hard drive so that I can refer back to it or copy it from another project over. But it's always good to check the manufacturer's tolerances to ensure that you have everything right and you don't send them something they can't build. So there's that. So those are the constraints. Now, predefined sizes, this will be used when you're actually editing your board. You can predefine set sizes for traces, for vias. That way you're not, you don't have a board with like 50 different sizes of traces and you lose track of what you set for each. I usually go with 1 to 4 or 5 different trace widths depending on the complexity of the board. Typically I'll go 0.25 millimeters on my traces, but if you want a more current carrying trace, something that can handle a bit more current, you can go thicker, and I believe IPC has standards regarding that. Additionally, going back to KiCad's calculator tool, you can calculate the trace size based on a certain amount of temperature increase you'd allow. But here I'll just go 0.25, should be enough for the entire project actually, I won't complicate it. So 0.25 should suffice. Now vias, we will also set the diameter of the via as well as the hole diameter. So the via diameter is the total diameter including that copper ring. I will set that to be 0.35 works. And then the hole diameter I'll set to be 0.25. Just a hair above what they're able to make. Actually, I'll set that to 0.4. May as well make it large. Easier to see. All right. I don't know how many of you know what differential pairs are. They're sort of a form of transmission line. I won't go into it here, but they're essentially two traces running beside each other. But I will leave that as is. And then teardrops. Oh, this is new. I haven't looked into this, so I'll let you guys explore that. This is usually to create a bit of a copper area between your trace and the circle to, prevent sharp edges. It's very useful for higher frequency applications, but I will leave that as is. You can tune length for traces, net classes, custom rules. Yeah. Constraints is all we need to worry about, as well as predefined sizes. Everything after that is sort of explore, if you ever feel you want to. So, yeah. All right, if that is it, then I will move on. All right. So is everyone set up? Everyone's comfortable with how things are? If so, then let's move on to importing our components. To import components from our circuit, we would press this guy here, or press F8 is a shortcut for it. When you press this, it will load in all of our footprints. So this is why defining the footprint in the schematic editor is so important. It essentially allows us to hit that, no errors, that's lovely. It allows us to import all of our mounts where we actually connect the components to the boards. So after you close out of that window, it'll sort of just float around with your cursor. Once you hit left click, it'll place them. Normally with larger schematics, you'll have an overwhelming amount of footprints that you need to sort through. Normally I will sort of group footprints based on function, kind of keep them all together, and then as I'm building the board, I will place them as needed. Yeah?
Does it matter like the orientation?
Orientation shouldn't. However, if you ever want to rotate components and footprints, I think, yeah, R is the shortcut. Similar to the schematic editor. So the orientation shouldn't matter for a lot of these components, because as long as you can make sure you can put the component on, you're good. It shouldn't affect operation at all. And we will be rotating components to better route traces to each component. I'll zoom in here as well so people can see. All right.
There we go.
So this is what our footprints look like when we place them. As you can see, everything is red and yellow. The yellow is your silk screen, so that's going to be sort of an ink that is placed on top of your board so you can read it. And you can see that the reference designator is listed as well, so that when you look at the board, you know what component goes where. So we'll have that. And I'll just throw these, kind of group them together left to right, similar to how we drew them in the schematic. Yeah. Now, if you guys are wondering what these lines going across between each component are, that's what's called a rat's nest. And the reason it has that name is because when you have a large design, it is a rat's nest. It is very dense lines. But what each line what each line represents is a connection. So between, for instance, this resistor and this diode, you can see there's a line. That means that this resistor will connect to this, like this pin here will connect to this pin here. And when we go to place traces, it'll help us sort of figure out where to route those traces. Now, usually it does help to have two displays when you do this, so you can watch both the schematic and the circuit, the PCB editor. If you notice, when I select a component in the schematic editor and go back to the PCB editor, it will select that component on the PCB editor. So it helps you figure out what component is where. And I use that function quite a lot when I'm designing the circuit, especially with the layout. For instance, if I want to know where Q1 and Q2 go, I'd want to place them sort of close by, and then Q3 can go over there. Loosely following the way you lay out the schematic does help with the PCB layout too. So I'll just do that, and then the resistors, if I go back to the schematic editor, I've got R1, R2, R3, and R4. I'll throw R1 right here, R2 right here, and R3 and R4 can stay right where they are. So, and understanding how to organize a PCB layout is sort of the art of PCB design. It takes a bit of practice. I know even with some of the boards I make nowadays, I will put together components on a board. I have it done. I know it would work if I send it to manufacture, but it looks ugly. So the voices in my head will get me to remake it. And so then there goes another 2 hours, 3 hours. It's iterative, and if you want to make a really nice looking PCB, it does require some practice. But in this case, we have a very simple design here, so it shouldn't be too hard. Now I'm going to rotate these two just so that they are there. Okay. Also, so if you ever want to see what your board looks like, KiCad does have a 3D viewer. So with this mess of sprawled out footprints, we can see what that looks like. And to do so, I believe we can go to View, 3D Viewer. Alternatively, you can hit Alt-3 is the shortcut for that. And when you click that, you can actually see the board. Now, of course, this is fairly ugly because we haven't done anything with it yet. But if you ever want to sort of have a visual representation of what your PCB will look like, I tend to use this pretty often. All right. Now with that said, I will start by routing traces. Now to route a trace, we will want to set our track width, our trace width. To do that, we'll use our predefined trace width by hitting this drop-down menu and selecting it. So if I select it like that, now that trace width is by default going to be used with every trace I make from here on out. And to create a trace, we can hit X is the shortcut, or we can click on this symbol here. And then that will allow us to draw traces. When we want to draw a trace, actually, the crosshair will snap to the nearest pad, the nearest pin of a component. And when you select it, you can see where you need to connect your traces. So, for instance, I need to connect this trace here is one of the pins that trace will connect to. And if you ever want to make a bend in a trace, you just left click and it'll create sort of a point where you can work off of. Not the prettiest trace, but it works. Now, before we place traces, typically you'd want to arrange your components the way you want it on the board. And I believe in my notes, I have sort of my previous design that I'll follow. That way I don't get lost. Because finding the right layout takes a bit of time. Cool. All right. So I will start by deleting the trace I just made, so it's not in the way. And the reason I do that actually is as you move a component footprint, the trace does not adapt to the way you move it. So you will have to redraw traces every time you move components. Okay. So I'll let you guys arrange your boards sort of the way you see fit. A lot of the times it does help to watch these rat's nest lines and sort of have an idea of how you're going to connect pads. For instance, this line crosses over this line, meaning when you draw a trace, you might have to find a way around that. And as you guys sort of work around that, I'm going to arrange these parts. Any questions so far? Yeah?
Is there any like automatic trace roller buttons?
I believe one exists, but ever since the moment I started, I've made an effort to never use one. It can be helpful, but typically when you design a board, you want to make sure every part works the way you want it to. Now, it does help speed things up in that it could help sort of place components where they work nicely together, and then you can sort of work off of that and edit it. But me personally, I've just never actually used it, so it does exist though, yeah.
This software as well.
In this software. I believe, I've never actually seen an option for it, but if it doesn't explicitly exist in the software, I guarantee you there's a plugin for it. So yeah, someone made a way to do it for sure. Yes?
How do we know what to trace? Is it just like anything that needs connection?
Yeah. Yeah, basically any point that needs to be connected to another point would be a trace. Yeah. Yeah.
So the layer selector's at the top.
Yes.
Only letting me see one layer at the top. Is there...
You should be able to see both. And actually, that's a great question. If you ever want to place a component on the opposite side of your board, if you click on the footprint and right-click it, you will be able to change the side. Alternatively, the shortcut would be F to flip it to the other side. And when you do so, you'll notice it changes color. That is because it is now on the back side, or back copper. And I can demonstrate that by going into the PCB viewer. You can see that that battery holder is no longer on the front. It is sitting there on the back. So by hitting F or right-clicking and selecting change side or flip, you can essentially put that component on the opposite side of the board. Now, being that these are through-hole components, besides the battery connector, you'll notice that each of these components has pads on both sides. And I'll go into, when we draw traces, I'll show you guys how we can route traces sort of across each other using the two different layers. Now, as you guys are routing components, how many of you have seen this? Has anyone ever experimented and checked what would happen? So essentially, what this is, and you can see it by the pink line around each component, those are what we call courtyards. And those courtyards define sort of that component's personal space. So you want to keep all the components outside of each other's courtyards, otherwise they're interfering with each other and you won't be able to pass that design to manufacturers. However, if you have a component on the back side, you are able to overlap a little bit. Except for that through hole there, that little pin there, if I put that inside the courtyard of that back component, then it'll get mad. So it does help to understand sort of what that component is, and the footprint being that it's through hole, it has both a front side and a back side. So there is that. But I will throw this battery holder right there. These transistors can go right there. Sure. All right.
When I'm getting the problem,
Now with the layout of components, as you rotate and bring components together to sort of create a more compact design, if the reference designator ever gets in the way or overlaps with another component, you are free to move it around. There is no constraints on how you position the reference designators, as long as the designator is visible when the component is on the board. So putting it in the middle of that component might not be the best idea, because as the resistors put on, it hides it. So I will just throw those. Gotta zoom in.
You might have the problem. Pull it down.
Okay.
Yeah, we have to use this first.
All right. So one crucial step as well that I sort of glossed over is the board size itself. Now, if you don't have a constraint on the size of the board you want to create, you can place your components and arrange them before defining your edge cuts. But say you have a constraint in your design, that would be, say, an NVMe SSD card has a specific dimension that it's required to have. You'd want to draw out that edge cut before you create your layout. So in this case, I'm going to draw the layout or the edge cut as you guys are sort of drawing your board. I'll quickly do this just so you guys know how. So when you want to draw lines, just regular, you can select which layer you want to draw on. So I'm going to select the edge cut layer, and I'll start drawing around my board. Oops. And then as you do that, this is where having the full screen crosshair helps. So then you can line it up really nicely. Right. And when you create those gray lines with the edge cuts layer, that will define the size of your board, so that when I go to check it in the 3D viewer, you can see I set the board size. So I know I sort of ran through that. I don't know if, does everyone understand sort of edge cuts and why they matter? If so, that's good. Now, how many of you are happy with your layout so far? Is it going well, or is it sort of a train wreck? Yeah.
Okay, sorry, so just to confirm, like all the blue lines, we need to like measure this in measure.
Yeah, exactly. Yeah. And actually, with the blue lines, the rat's nest lines, if you're annoyed with them being straight, you can make them curvy. That is an option right here. Actually, you could disable them entirely. But I tend to have them curved so that when I have multiple lines, I can see which one is where. But yeah, entirely preference. But yeah. And then all right. Yeah.
What happens if I make a point, but it has like nothing to connect to, and I like try to make a wire?
Which component are you?
It's Q2.
Q2.
It's like the left thing. I have it like oriented in this.
All right, we've got that pin. that pin goes there, this pin goes to this. Yes.
Yeah, I don't know, I might have,
If you don't, if it doesn't have like a connection going anywhere, usually that means that we haven't defined where that pin goes to. So if you go into your schematic editor and correct that, then it should hopefully fix it. Otherwise, an additional thing you could do is select the pad, and if you right click it and go to properties, you can actually set which net it goes to. This is sort of more in the getting into the details of what circuit you have and all of the different nodes in the circuit. But yeah.
where's it supposed to be? Yeah.
I think, well, I've got it here as Q1-B. So if you right click and check yours, what does yours say?
It's not opening the, is it the properties of Q2? Oh, yeah.
Yeah, if you go to just the pad itself.
Okay.
Yeah.
And then connections?
No, it's just right net name.
It says unconnected.
Okay. So if you go to your schematic with Q2, that is the square pin, which is pin 1.
Yeah.
So that means this bottom pin connection on your,
It's not connected.
yeah.
Oh, okay.
So that would be it. And then when it is connected,
It's not. Oh,
yeah.
So I need to.
So if you draw that, but I'll show you, because this is something that's actually, it's good that you had this problem, because then I can show you something. When you make a change,
My Q2 is your Q3, I think.
okay,
Yeah.
yeah.
Oh, that should be a ground there.
Yeah, there's ground there, and then, yeah. Now, when you make a change to the schematic,
Yeah.
one thing to note is when you go back to the PCB editor, it won't change right away. To update all the changes you make in the schematic, when you go back to the PCB editor, you want to hit the same button, F8, and when you do that, it'll make all of the updates. So for instance, if I go to the schematic editor, you guys do not need to do this. I'll just use this as an example. Say I had the wrong footprint for this resistor, and I wanted to set the footprint to the correct one. I forgot how long it takes to load. After changing that footprint, I would go back to the schematic or the PCB editor and hit that update, and it'll update that component.
Okay. So it's just to make sure to like update this.
Yeah, exactly, yeah.
Yeah. We'll just go to the schematic.
Yeah. So to update it, I'll show you right now. So with the, say I have the wrong footprint and I needed to update it, I will do this, axial R. Okay. Say I wanted this footprint for a resistor. I'll just select that, hit OK. When I save this schematic and go back to the PCB editor, nothing's changed. We need to update this. So to update this, we'll do the same thing that we did to start, and that is hit the update PCB. And when we hit that, you can see in the background there, our footprint updated. So yeah, that's the process. And this footprint is actually kind of cool. You can see how tiny it is. If I go into the 3D viewer, you can see how the resistor is positioned. Oh, whoops, Alt 3. You can see how the resistor is now sitting vertically on the board. So that footprint would be to sort of save space, usually, but yeah. All right. Now, as you guys do that, I will quickly make connections, and then I'll go over different layers as well. What's happening? Are we behind?
Like a lot of people.
Oh, a lot of people are behind.
How feasible is it if you're able to like redo this, like put it like quicker, like just redo it? Yeah. I think a lot of people are like stuck on importing like the components from the schematic
All right, raise a hand. Who needs to go over importing the components again? Or is anyone stuck on the...
I think it's like after maybe importing components before starting.
Ah, okay. All right. I think, yeah, there was a question.
I was just gonna ask why your battery.
Why the battery's on the back? Or blue? Yeah. So the blue means it's on the back. So to get, I was using it as an example on how to bring components between layers. If you want to have the battery on the front, you would right-click it, and we can hit Change Side, and that'll change which side it's on. So the blue means it's on the back side, while the red means it's on the front side. Yeah.
How do you go over moving the little things around?
The which?
Where it says like R3,
Oh yeah, you can individually select it, and then when you individually select it, it'll move around the footprint that you've got. Okay, so I've got that. Now, yeah. Oh, if you go into your layers, make sure you've got most things. If you can't see certain layers, it does help to check here. If maybe you hid it. If it is hidden, then that could be why. Otherwise, I believe this option here on the side hides or dims layers that you're not using. But yeah, check your appearance and make sure that you have things shown. Did you figure it out, or?
Which one?
The ones I would have selected are, if it is hard to see, I'm sorry. Make this bigger maybe? Not really. That doesn't help. All right. I have front copper, back copper, front copper. The first two here are shown. And I've got silk screen is shown. So this would be, if I hide that, then I'll only see the red. But if I show this, I'll get that. Same with the back silk screen. So maybe these are what you need to show. Did that work? Okay, yeah.
Is there a way to like delete a wire view and then like individually clicking?
You can highlight and select. If you go to the selection filter here, you can choose only tracks, and then you can highlight, and that'll allow you to select multiple.
Highlight the track as well.
Yeah. Otherwise, yeah, it would be individually just click, delete, Yeah.
Is there a way to check if everything that needs to be connected is connected?
Yes. And to do that, we would use the DRC, the design rule checker. That there. Otherwise, just looking at the circuit and seeing if you have a rat's nest line usually gives away if you're missing something. Yeah. Okay. So, yeah.
Does it matter if you like root any traces underneath?
Not at all. No, you can have traces go through sort of like that. It's totally fine. Yeah. All right.
Is there a way to flip which direction goes? Sometimes when you try to draw it at an angle, it's like down and diagonal.
Usually, are you talking just the trace?
Yeah.
The way it auto routes traces can be a little bit finicky. Even I have issues with that. So what I'll do sometimes is I will place it, and then I'll just click on it again and manually move it around. Yeah. So you can play with that a little bit too. Okay. So I will start placing traces just really quickly here, and I will show you guys how you can place traces on both the front and the back to get that. And if you ever have selection filters enabled, as you can see, I can't really click anything. I have to hit that, and now I can. So that's one thing. Yeah?
How do you put the battery on the back again?
F. Or you can right-click it, and it'll have an option on that context menu, yeah. All right. Is it good? Okay. All right, then I will begin to arrange components and traces. Now, if I want to place a trace on the backside, I would want to select the layer that I want to draw on by hitting back copper, and then I can connect the battery terminal to all of these guys. And I'm not going to be too particular about this design. And then say I want to connect traces on the front, I can do it this way. Oh, this is turning out great. All right. Sure. All right. Now, say I want to put this trace on the back side, I'll just switch over to the back by hitting our layer appearance here, and then I can cross these over since they are on different layers. And I'll go over some of the best practices and techniques that make designs a little bit more efficient after we lay out everything, but yeah.
If I make like a really bad setup of the tracks, can everybody just like punch them off?
Yeah. Okay, so say I'm unhappy with my tracks right on these transistors. If I go to the selection filter and deselect all and just select tracks, that means I can't select any component, but I am able to select the tracks. So if I really don't like this whole area, what I can do is I can just highlight it and then hit delete, and they're all gone.
Michael, I have a question.
Yeah.
Do you ever want to put components on both sides of the board?
Yes. Depending on your application, you might want to put components on the back side. Say for instance this battery connector. If I want to make a more compact design and this battery connector fits maybe over here where I can have it maybe like that, right? Then I'd want to have it on the back rather than if I have it on the front, it's interfering with different components. So by hitting F, you can move things to the back side, and same with the switch. If I wanted the switch to be on the back side, I can do it like that, and then if I go into the circuit editor, you can see that switch is now on the opposite side. However, in our situation, we want it on the front, so I'm going to bring that back to the front, like that. All right. Now,
Quick question.
yeah.
Is R4 like really small because that's like the one that was 470?
No, I was just I just switched the footprint to show how to update the board, but honestly, the resistors we chose here are massive for the application. Normally in the data sheet, it would specify the actual wattage that the resistor is able to handle, so the amount of current and voltage across it equates to power. And that would be more of a curated to your design. You'd sort of know what to use in that case. But in our case, I'm just grabbing whatever.
Does it matter which order we place them in?
No, it shouldn't. As long as they're electrically connected, the circuit should theoretically work. Yeah, so. Now, when I'm placing traces, I will typically do ground last. When you zoom in on the pads, you can actually see what net it is. Ground I tend to leave for last because what we do is we fill in the empty space of the circuit board with copper. And normally that copper would be set to be our ground. So as you can see, I was laying out the ground trace here, but in our case, I will not include it. And I'll proceed to continue. Actually, this diode should rotate. Boom. Okay. Sure. Okay, so I've gotten to a point where the only rat's nest lines I've got are between the ground. I'll leave it like that for now, but does everyone understand sort of what I did there between the back and the front traces? As you can see, sort of down by these two transistors, I've got the blue and red sort of overlapping. Yeah.
How were you able to switch between the front and back again?
To switch between the front and back, all I did was select which layer I wanted to draw on, and it'll show a little arrow beside the layer that you are drawing on. So when I draw it, it looks like I'm switching between the two somewhat often. Yeah, and then by switching between the two, you can see I'm drawing on the blue side. Actually, hold on. If you select a back layer, you can draw on it between the two, but if I want to explicitly just draw that versus this, then yeah, you can switch between the two. Anyone have any questions while others are sort of drawing? Yeah. Yeah. You can follow this design if you want. I sort of haphazardly drew this, so yeah. And as you draw, you can actually see where your traces are when you go into the 3D viewer. They do show up, and you can kind of visualize how each component would be connected. As you can see, I've got two traces over here, and on the back side there might be some, these traces here on the back side, so you can switch between the two and see what's there. Okay.
Yeah, you should,
All right. Here's an And if you guys are curious as to the finished design, this is somewhat what a complete board given. Wow, it's loading quite a bit. If you give it a bit of time, you can make a board that looks a lot tidier. I think this was the second iteration of the board. The first iteration was not pretty. And the board layout would look something like this. If you get it, it could be a little bit more complicated. But for now, this will suffice. So, yeah. I would, to define the size of your board, if you go to your, here, let me see if I can shrink this. Go down there. Okay. If you go to your edge cuts layer here, What you can do is you can draw using this line, you can draw the board shape. So anywhere there's gray is sort of the inner bound of your box, and when you create a complete closed loop, it'll make that your board. So what I did was I drew a rectangle around our board. Additionally, what I could do is give it a little bit of character and throw on a arbitrary angle there. And then, yeah, that's a complete loop all the way around with gray, and you can sort of size it right. And if you ever want to do like specific dimensions, you can also go to the properties of that line and set the endpoints or length and angle of that line. So you have a lot of control over all of your stuff in the properties dialog. And then I think that'll, yeah, the edge shows up, yeah.
If all the little blue lines are gone, does that mean everything's
Yeah, pretty much. As long as you have the show rat's nest selected. If it's not there, then nothing will show. But yeah, if everything is connected, then you shouldn't see any blue lines. Yeah. Well, here I kind of ran through that really quick because I realized I forgot to do it at the start. But here, I'll delete the edge and I'll go through sort of designing the board shape. So to create your board, say I want specific dimensions. What I can do is I can select edge cuts, and under edge cuts then select the draw line. Alternatively, you could also draw a rectangle. I believe that works too. So you can draw it to specific dimensions, or if you have a more arbitrary shape, you can draw it using lines. And then using that, you can measure it out, and you sort of just draw a closed loop. And when you create a closed loop like that, that should define the general shape of your PCB. All right. Yeah.
Is there a way to like create another PCB bench just to see if I can make a better one? Can I scrap it?
So you could scrap it. I know what I do typically is I will go through, and if you're really unhappy with the way you have it, I just delete all the tracks. So I'll go like this, select all the tracks using the selection filter here, and just, yeah. And then I start over, rearrange as I want. Because sometimes maybe you have a large PCB and you really dislike only one area. It's good to do it through the selection filters instead of just completely recreating the project.
Yeah. Is there a way to have a duplicate version of it just to see?
Yeah, you can just take the folder, copy and paste, and it works. Yeah, it works great. I know I do that all the time too. Yeah, there's a question. Yeah. What was that? Are you talking about the rat's nest lines or the traces? Like these guys? Or are you talking like these guys here? Oh yeah. So the rat's nest, if you want to, you can get rid of them entirely by hitting this option here, and it'll get rid of them. Alternatively, if you want them to be straight, you can use this or make them curved. What they represent is a connection that hasn't been made yet. So in my case, I've got a bunch of them, mainly between the ground connections, just because I haven't connected all the grounds yet. They'll disappear when your design is at its final stage, kind of complete, but yeah, those just indicate, so you can't really select. If it isn't connecting for certain components, you might want to, do you have a trace going to each one? Because typically to connect, say for instance this, this line here between these two paths should go away the moment I place a trace on it. Yeah. There's a question there. You go down here. If you do the selection filter, usually it would be on all items. But if you deselect that and go to tracks, then you should be able to highlight everything and it'll only select your traces. Yeah. And if you're ever curious about like an option or a dialogue or something that you're seeing on the software, just feel free to put up your hand and ask, and I'll see if I can explain it. Now, one thing I neglected to mention is you can change your snap grid. So if you want to have better control of how close your traces are or where your traces line up, you are able to do that by hitting that, and then you should be able to, yeah, for instance, I clicked so close to that because it's just slightly off. But should be able to do it like that. There we go. And that does help with positioning components as well. So with a raise of hands, how many of you have gone sort of to this point? I don't know. Yeah? Okay, so a good number of you. Anyone have questions for those of you who haven't? Yeah? No, we're going to move on from here, but I'm just giving time. Okay. So I think a good number of you have already gotten to this point, so I'm going to go over sort of the final step of the board. I'm going to do the copper fill, which sort of fills in all the empty negative space of the board that isn't used. So, getting used to the zoom. All right, so to do fill, yeah. Oh, where? Oh, yeah.
How do we know that all of our tracks are like?
So we know our tracks should be connected. How we know that is we don't see as many rat's nest lines. So those little rat's nest lines sort of really help. I always keep them enabled. In the case of this board, you can clearly see that there's still some that aren't connected, but those are just the ground pads. And I purposely leave them unconnected for this next step actually. So this next step I am going to will show how to get rid of those last bits of rat's nest lines. So I'll move that up a little bit. There we go. Okay. So the last step to sort of creating this board, at least the brunt of it, is doing a solid fill. What a solid fill is sort of just huge, large areas of copper that are assigned to a certain net. In my case, I'm going to assign it to ground, so we have a large ground plane. And normally I would set this to be the same size as the board. So I'll just click each corner. I'll change my grid size so it snaps a little easier, but I will select sort of the corners, and when you click initially, it'll pop up with this dialog. You can select which layers you want this fill to affect. In my case, I'm going to do a fill on both the front and back, so I'll select the front and back copper, and I will assign it to the ground net. You can also set it to any other net, but typically I would just recommend using ground. It works the best. And then I can do extra stuff to it, give it clearance, the clearance around sort of traces that aren't assigned to that net. In this case, I'm going to set it to 0.3. It is entirely preference which you choose. And I will set this to low area limit. I'll keep it as always. Okay. And the moment I hit OK with this, it'll give me this line, and I will start to draw out my border here, and you can see it fills in red where the fill will be. And I'll finish it by double clicking. And when I do that, you can see how it's got this sort of hatched border. That defines my fill zone. And then to actually have the fill occur, I believe it would be under Edit, and then you go to, or is it View? No, Edit, yeah. And then you can do Fill All Zones. And when you do that, you can see it's very red now. That means that wherever there's red, there's copper. And then same thing on the back. You can see that everywhere there's blue, there's copper on the back. So pretty straightforward, I'd say. And if you ever go into the 3D viewer, you can actually see now it sort of looks more legitimate in terms of a PCB. Yeah.
If we have a really weird shape, what should we do? Should we try to draw the complete outline?
Are you talking about like routing the trace, or are you talking about the fill zone?
Yeah, the fill zone.
Yeah. You can do like yeah, you can totally do that. Say for instance, I have an awkwardly shaped board. What I can do is I can do sort of selecting, say I want to have a circle fill layer on the front. I'll do that. I'll hit OK, and I will just start drawing as I see fit. Yeah, like you can get creative with it, and sometimes you can do like a drawing within your fill zone. And then to finish it, you just double click, closes all the loop, and then you can hit OK here. And if you go to Edit and go down here to fill all zones, or you can just press B and it also does the same thing. And you'll have your awkwardly shaped fill zone on your board. In my case, I will go back to my entire board outline. And with that done, you can kind of see that, well, you can see that there are no more rat's nest lines. This means that all of our nets are connected. Yeah. Once you outline, have you outlined the fill? Yeah. Once you outline the fill, if you go to Edit and then go to Fill All Zones, it will fill it all in, or you can just press B, and that's the shortcut key for it. Yeah. Okay. Now, on this PCB, I have a big area where it's just empty, free real estate, and maybe I want to draw something there. This is where we can use something like the silk screen to create text or a drawing or whatever else. To include silk screen, you would select the layer. So I'm going to do it on the front here, and I'm going to put on text and say I want to put on IEEE UBCO student branch e-workshop 2025. Say I want to put this text right in that empty space. I can type it and place it down like that. And then now when I go to look at the board in the 3D viewer, you can see the text has shown up. So that'll be printed on your circuit board when you get it manufactured. Alright. So with a raise of hands, how many of you have gotten this far and whatnot? Yeah, question? And just speak a little louder so I can hear him. The copper fill? Yeah, I can go through that. So, have you drawn the copper fill? You've got the outline? Yeah. So when you want to actually fill the copper zone, all you have to do is go to Edit, Edit, and under Edit, just at the bottom here is Fill All Zones. And when you click that, it'll fill the zone. Alternatively, you can just press B and it'll also fill. Yeah. I think I saw a question. No? Yeah.
Can you please go over how to make like the boundary like one more time?
Yeah. Okay. The edge cut or the... to click on the edge cut first. Okay. Yeah, so to create the edge cut, I will redraw it again. What you do is you select the edge cut layer right here, and then all you have to do is all of your drawing tools are just on the side here. Yeah, and then when you draw it, you can lay down lines, or you could also do a rectangle. It actually might be easy to do a rectangle. The issue with the rectangle, though, however, is when you select stuff, maybe it'll automatically select your border and you move it around and it's like that. A cool trick with that is if you ever want to lock a component or a line in place, you can go to the properties and you can select lock. Yeah, and then that'll prevent it from moving around. Yeah.
What do you do if you don't have the text on the line? It just doesn't.
Or are you talking like right here, it cuts off just before here? Okay. I feel like 2 years ago someone had the same same problem, and I don't know if it was, you have to resize the window. Does it have a scroll bar beside it or anything? No? Man, that's wrong. Let's see. If I do that, yeah, I can see how the text is cut off when I do this.
Or if you go place, you can skip it to line.
Or are you able to?
Yeah, if you go place it to top, you can get the whole list.
There you go. Context menus for the win. Yeah. All right.
Because you know how these equations are thin.
If you've gotten to this point, the board is pretty much done. All you need to do is export the manufacturer files, which I'll go over. But in the meantime, while others are getting caught up, you are totally free to add silkscreen, play around with some of the drawing tools. If you ever want to draw on the front side or the back side silkscreen layers, all you have to do is select the proper layer on the side menu. For those in the back who can't really see it, it's labeled as F and B silkscreen, F silkscreen and B silkscreen. And when you select those layers and draw, you will then be able to see that drawing on your board preview right there. So get artistic if you feel.
So is this on like the back layer?
Yeah. Yeah, so all of the layers here kind of have a prefix of F or B, which tells you if it's on the front or back, yeah.
And then do you fill it with something like on the back side?
When we do the fill, we can do individual layers for fill, but I selected both the front and the back. And when I click here, oh boy. Okay, I'm going to select the copper layers and then do this. There we go.
Yeah.
Once you can fill an entire area with like silkscreen if you want, but when you do it with the copper layers, it'll show up with this prompt, and you can select both the front and back copper layers here. And I select ground, and okay. And then when I draw my fill, and then fill it, there we go. So now that generates a fill for both the front and the back.
Oh, okay.
Yeah, and you can individually do different fills for each as well.
Yeah,
Yeah, especially for some of the more complicated board shapes.
For me, when I click on like the back side,
Yeah.
it also shows red. Not like the fill color is also red. Is that just like a setting or? Like the wires are blue, but the fill is red.
Are you able to rotate so I can see?
Oh yeah. So that's the back side.
And you have that layer selected. If you do a fill,
I didn't select both.
yeah, if you do a fill with only the one side, here I'll deselect that and redo it. Yeah, then it'll show up as red. Yeah, so you can edit it. You don't have to redraw it. If you just go to the properties and select, and then do the fill, it should change. Any questions? There's a questions? Anyone? Yeah. What? Okay. Do you have a closed loop? Okay. and you went to the edit and fill zones. Have you tried pressing B?
I think it was buzzed.
Okay. When you go to draw your zone, did you selected a layer, right? They were, the layer here is selected? Okay, and did you set, if you select your boundary, like the layer drawn, or the fill drawn, and just press E to get to the properties, you should open up a menu like this. Yeah. Are they? Okay. Yeah. If you select one of the copper layers and then redraw it, maybe there was an error somewhere in there. I don't know. But give that a shot and let me know. Yeah. The 3D viewer. If you go to View and then 3D viewer there, or you could press Alt F or Alt 3 to access it. Yeah. No questions? All right. How many of you have had success with the fill? Yeah? Okay. Then I'll go over the next important part. I'll quickly save this though. Control S. I don't think this software has autosave, so it is important to save. What was happening? Are we good? Okay. All right. We've got about 15 minutes left, so I'm gonna go through how we can export manufacturer files. This is our complete design. It is as complete as can be. When we complete our design, we want to make sure it follows all of our constraints. And to do that, what we want to do is click the design rule checker. What this does is it goes through the position, all the layers, all the traces, and makes sure there aren't any errors or illegal moves. For instance, like traces too close together maybe. And when you click that, it'll show you all of the errors. In our case, we have one warning. And it's due to my circle being connected to a pad. So in this case, it's a warning. The manufacturer can still build the board. However, I don't like that, so I'm going to delete this circle. There we go. Okay, and then once that's done, what we can do is we can run the DRC again, and it'll show no warnings, no errors, and that means our design is good to go to manufacturer. So once that's done, what we want to do is we want to go to File, and we want to look at fabrication outputs. So we have a bunch of different options, and some manufacturers will require certain outputs. In our case, we're going to go with Gerber's. So that is File, Fabrication Outputs, Gerber's. And when we select that, we'll be given a very comprehensive dialog. And in this dialog, we can select which layers we want to export and send to the manufacturer. In our case, we do want the copper layers. We want the silk screen layers. We don't need the solder paste layers. And we want the solder mask layers and edge cuts. Edge cuts are important too. You can easily go through and select which layers you care to have exported. Yeah, and I'll leave all these deselected. You can choose which directory you want to output your Gerbers. In this case, I'll create a folder. You do not need to, but I will. I'll name it Gerbers, and I'll select that. There we go. So I can select where the Gerber files will be outputted. It will create a file for every layer, and that's how the manufacturer knows how to create that layer. A lot of these general options here are based on what settings you want the Gerber to have. In our case, we don't need to touch any of it. It'll be fine as is. Actually, all of these settings are good to go, so I'll just hit plot, and when you hit plot, it'll create all of the Gerber files. And as you can see here, those are all of our files. They'll show up in our project folder under the directory you chose. And these are the files that we will send to the manufacturer. However, there is one more set of files that are important. That is where to drill. Can't really have a board with through-hole components and no holes. So if you go, once you create the Gerber files, you'll go to Generate Drill Files just at the bottom right corner here. And when you select that, in the same output folder, we will create Exelon drill paths. And a lot of these settings you can leave as is. The manufacturer will be able to use them like that. And when you hit generate, it'll create your path and end path files, DRL files, which are your drilling paths. And then once those are generated, you can close that, close this, and we'll have all of the files we need for manufacturing. So I went through a number of options there. Did everyone follow along yet? I can do it again. Let's do it again. Okay. So, to do it a second time, I will go to Fabrication Outputs, and I'll select Gerber. And when I'm in here, it'll give me a dialog where I can select which layers I wish to export. In our case, I'm going to go with the copper, the silk screen, and the solder mask, as well as the edge cuts. You are able to play with the options. However, KiCad has the defaults set out, and manufacturers are good with these defaults. So I'll leave the defaults the same. I can select which output directory I want to go to. So if you have a separate folder for the Gerbers, you can do that. In this case, I created a folder named Gerbers, and I'll save to that. And then once you have all the settings you want, all you have to do is select plot, and it'll generate all of the files. And then once all the Gerber files are created, you are able to create drill files just by hitting this button here at the bottom left corner. And when you hit that, it'll open up this window. And in here, you select your same output, and all you have to do is hit generate, and it'll generate your drill path files. So, is everyone good with the process there? Right on. Okay. Now, sort of the last step to this would be going to the manufacturer's website and uploading those Gerber files, which I can briefly go over. I'll go over it in the next session in more detail, but just to show you what that process might look like in advance. If I go to, say, PCB Way, and I go to their instant quote, I am able to upload Gerber files. And from there I can add Gerber files. In my case, what I'll do is I'll open up my project, Gerbers, and what I'll do is I'll create a zip file from this. Every computer, you guys all have either Windows or Mac. Create a zip file however your system does it. And when you create that, you've got your zip file. And when you go to upload it, boom. The website should detect all of the layers. It might give you a preview, otherwise, I guess not. maybe it will tomorrow. But yeah, from here you can select all of your options for the manufacturer of the PCB. But yeah, that's the that's sort of the beginning to the end of creating a PCB. But yeah, at this time I'll take any and all questions. I'm here until everyone else leaves, so yeah, I think that's pretty much all I've got to cover today. Thanks for coming. Yeah.
Are there any settings for like the DRC that I have to check before running it? Or
No, you just run it. So when we set the tolerances,